stage keynote, the future of AI is open. So I'm Marcus. I'm from Germany, part of Red Hat, doing a lot of technical marketing stuff. And I do talk a lot on stage, and I do introduce a lot of people in various contexts. But today is kind of a big fanboy moment because I have the pleasure to welcome Gerard and Sid from Red Hat and Intel, and they both are going to walk us through the latest and greatest of what Red Hat and Intel do together with this exciting topic around artificial intelligence. Gerard, take it away.
Thank you, Marcus. I will say, even before we get started, I had fun putting together this slide deck with Sid. I think the topic is very interesting and very relevant to where we are today. Lots of things going on in the AI industry. And the work that we'll talk about really highlights how this isn't new for Red Hat and Intel. We've been here before. And so it's a great opportunity for us to collaborate, in which we have been doing. So I'm very excited to talk about what we've been doing together, but then also some work that we've been doing independently that support each other. Really quickly, the agenda. I'll first talk through, the open source. I'll give you the introductions, myself and Sid, and then we'll talk through open source revolution, how open source is critically important to LLMs and the future of LLMs, what we're doing together with LLMs, both Red Hat and Intel, and what Red Hat's doing with large language models and generative AI. And of course, we'll round this out with what Intel is doing in this space. Just a little bit of background. I'm Gerard Griffin. I've been at Red Hat for about 6.5 years now, focused primarily on data and our AI and the ability for us to build products that help customers infuse their applications with AI. This goes for OpenShift AI. I head up the engineering for that, as well as our open source community, Open Data Hub. And then more importantly, I work with great partners like Intel to round out our ecosystem to ensure that our customers have the best choice of both hardware and software for their AI initiatives. I have with me Sid Kulkarni from Intel. He has a phenomenal background. He's been delivering AI and data solutions in 3 different verticals over the past 2 decades, anything from retail, finance, as well as ad tech. And Sid's currently the VP and GM of the data and AI platform at Intel, responsible for delivering the AI vertical apps in several verticals, as well as optimizing Spark installations. So I'm very glad to have him here. And I am actually going to go ahead and kick it over to Sid to get us started on open source.
So good morning and good evening, everyone. And thank you, Gerard, for that great introduction. Today, I'm going to talk to you about open source revolution. So I think you are already familiar that open source in itself is a revolution which started somewhere around in 90s and just it took by the storm. The reason it is a revolution is because it promotes collaboration. Obviously, it does provide transparency and security. The shared problems are solved much faster, and teams collaborating, communities collaborating and working together creates standardization. There are over 1 million open source projects that are now created. However, with the advent of LLMs, open source is even more relevant because of transparency of both the model as well as the transparency of data and the whole sensitivity around transparency issues and security issues. Next slide, please. So who else is actually saying this, right? So if you look at this interesting memo from Luke, which recently leaked out of Google, he says that we have no moat, neither does OpenAI. Open source is going to outpace any closed AI systems and is already doing so in several waves, this memo argues. So as you're fully familiar, LLMs actually took the whole world by storm around November of 2022. Since then, you have seen significant innovations and multiple companies making multiple announcements every month or every 2 months. This week itself, Meta and IBM are starting an AI alliance for leading technology developers, researchers, and adopters collaborating together to advance open, safe, responsible AI. This includes about 50 members, along with heavy hitters such as AMD, Dell, Hugging Face, IBM, and of course Intel, followed by Oracle, FastAI, Stability AI, and NASA, to mention the few. More recently, you have also seen the European legislation that ultimately included restrictions for foundation models, but gave broad exemptions to open source models, which are developed using code that's freely available for developers to alter for their own products and tools. This move could benefit open source AI companies, particularly in Europe. Let's go to the next slide. So let me walk you through a little bit of my experience as an engineering manager in building products and building product strategies. So previously, before the advent of the LLMs, typically you start a project, you start it small, you start putting it together with available open source components to keep the cost down, to run certain POCs, and then you kind of make a buy versus build decision. If you are creating an application that captures the nuances of your business and want to give you a competitive edge to you, you probably decide to build it in house. But if there is a solution that is available on the market, especially as a service model, I think you would normally choose that as a solution. So that is kind of the process I would go through while deciding buy versus build. Whereas today, in the advent of LLMs, it feels like it has turned by 180 degrees. So typically, first now people start experimenting with black box LLM services to keep the cost very low. But then after doing some experimentation and using the data in the open source, as well as using some of the fabricated data, then you start thinking about your own data and making your application more and more relevant and leveraging your enterprise data. Then the real data questions come in. You know, can I actually upload my data to a service? Am I risking my data? Is the service transparent? Can I customize the model or service? That's when you start actually bringing a model in and possibly fine tuning or doing a RAG on the model so that it becomes specific to your business and delivers you the competitive edge. Next slide, please. So with that, I hand it over to Sharad.
What Sid mentioned is something that we hear many customers facing, that challenge of, I want to get started quickly with my AI initiative, but how do I do so? And a lot of times that barrier to entry is, oh, well, let me just call this service and send it data. Even today in a meeting, the conversation was brought up, well, can I just use this service and infuse AI into our processes and develop our code faster? Well, what we're trying to highlight is the challenge and the difference in the delta, which you see now with LLMs, and how companies can pivot to having a more sustainable infrastructure to not risk the data and not risk security issues that you may have when dealing with a lot of these pop-up AI services where you don't quite know what they're doing with your data. Are they using your data to retrain? Are they using your data for other purposes? So if you need to have that infrastructure in-house in a way that is approved by InfoSec, approved by IT, I want to talk you through some of those requirements and what that looks like. For most companies that they first start playing around with LLMs and ChatGPT, and now they're getting to the stage to where they're done. They're kind of done playing around with those concepts, and they want to build products and services for themselves that take it to the next level. This is where they have to transition to really seriously investing in the AI projects. You may have had something run on your laptop, but now how do you roll that out into production at scale where the infrastructure is critical to the success of that, especially if you want to protect your data and run it in-house? When you're doing that, there are a lot of stakeholders that have to partake in this exercises. Now, you may have one or two people having a myriad of these personas, but regardless, we typically see this as the cycle that has to happen in order to get an idea from that early stage into it's been invested and infused, and now it's ready to roll out. This goes anywhere from your business leadership to provide the right criteria and requirements for you to design your systems around. the data engineer, the data scientist, the data scientists and the ML engineers working really closely together, where the data scientist may develop the model, but the ML engineer is responsible. Think of it almost like an SRE type of role. They are there to usher that model into production and provide capabilities like roll forward, roll back, and ensure that metrics are being collected. But even more critical to that is the application developer. If you roll a model out into production, but you don't have an application that rounds out that experience, then for all intents and purposes, it may not be all that useful. Imagine ChatGPT without the application that went with it. And so that's the criticality of the application developer's role. They need to understand and have the right ability to work with the models and infuse their applications with AI. And across this, every single team member plays a critical role in this complex problem of getting things to production. And when you start to look at this holistic view, this can be very expensive if you were to try to replicate some of the cloud services. And Sid will talk about the cost of a lot of this down the road. But what I want to highlight here is you have to start thinking about, if I want to run these projects and go from ideation into a seriously invested AI project, you have to think about the cost of CPUs, GPUs, memory, and even what it could represent if you're using cloud cloud services, EC2 instances, Google Cloud. That has an inherent cost. And so these are all the things you have to start thinking about when you're delivering the solutions for this. Now, this is where I'm excited, because the work that Intel and Red Hat have done together helps you optimize on the execution of the models as well as the cost, in order to ensure that you're building on a system that is scalable and you can support long term. One of the key parts about this is the industry has moved away from, at least when you talk about how you can apply this in your own local environments, they've moved away from a lot of these large language models that are, billions and billions of parameters, some of them 100 billion parameters, very large sizes in the gigabytes of sizes. They've gone away from that, and they've started adopting more industry specific, smaller foundation models that can be tuned and you can do inferencing on it with a lot less hardware. Now, you combine that with some of the innovation coming out of Intel and Red Hat, then you have a really powerful ecosystem. So if you look at the left side of this, I want to talk a little bit about what we've done on the training and validation side. We have great technology that allows and all of this is OpenShift AI, what I'm going to talk through, and it all runs on OpenShift. On the left side of this, what you see is a lot of technologies that are geared towards being able to do distributed processing of the data, whether that's where you need to fine tune it and you need to use all of your infrastructure to do that, or optimize the usage of that, or even down to, I just need to train a model. How can you do that in a way that allows you that scalability, that elasticity, even in your own data centers? Then we have technologies like MCAD, which allows you to optimize the queuing as well as the priority order of your training jobs that are running. If you have 10, 15, 20 data scientists all needing to train the data, then you need ways to optimize that. We also have InstaScale that allows for dynamic scaling up and down of the clusters. So if you have a job that's more resource intensive, you can pass it the information that you need to scale it up and down. And it'll save you on resources as the job is done. It's going to scale that infrastructure back down for you and instantly save you on cost. Now, on the right side, which is more on the tuning and the inferencing side, we've done some great work with Intel. They have their AI analytics toolkit as well as OpenVINO. Those are fantastic frameworks to be able to do more with limited hardware. That goes for anything from edge to just you don't have GPUs and you need to do CPU and still get really good performance. Those are great frameworks for that. For example, let's say you don't want to necessarily purchase GPUs for some of your inferencing, and you want to do things like quantization or sparsity. Those are great frameworks that allow you to do that and get GPU-like performance, but on a much more commoditized hardware. And you couple this with the smaller, more specific foundation models, then it can be very powerful. Some of the other things in this space that's fantastic, we've also been working on the hardware side with Intel and as well as the kernel level to optimize performance. If you do need GPUs, you can have that with what they're doing there. Also, fantastic work with the Xeon. They have upcoming capabilities there. Each release is adding more cores to the CPU, which is phenomenal if you want that more CPU workload. And then, of course, we have Habana Gaudi 2, which we work fantastic with Intel. And all this is done open source, right? All of these technologies are coming together to help application developers, to help MLOps engineers really optimize on, simple hardware, how they can adopt LLMs and foundation models into their ecosystem. Now, I talked briefly about OpenShift AI. I want to make sure I hone in on this point. We are focused on the AI industry along with Intel, but this is all being done out in the open. We have a lot of upstream projects, Codeflare, Ray, Kubeflow, Kserve. They're all feeding into our Open Data Hub upstream community project. And then that is what we have as our downstream product with OpenShift AI. And when you think about it, there are very few companies like Red Hat who have not only learned about open source, but they've survived all the myriad of changes that have happened, and we've thrived in open source. So with open source, Intel and Red Hat, it's in our DNA. It's what we've done. Intel has decades of experience in this space, going all the way back to being a key contributor to Linux. And so we've both grown from open source. We've lived in open source communities, and we're pushing the envelope even more in terms of how we can bring more innovation to the AI space using true open source patterns. And when we talk about OpenShift AI, what we're really trying to do is provide that platform that unifies the data scientists and the application developers. We give a platform for customers, an enterprise-grade platform for customers that allow them to develop, train, serve, monitor, and manage the life cycle of their AI and ML models. And then we're using OpenShift as that environment because OpenShift's already the platform that application developers know. They love it. They work in Kubernetes. It allows them to scale up their applications. And so giving application developers that AI platform that's in the same ecosystem, the same kind of patterns, the same ideas of providing the ability to manage your applications. We're applying that to machine learning. And what we're doing with OpenShift AI is bridging that gap between MLOps and operationalizing your models and the challenges there. And we're bridging that with what we're doing on the DevOps side of things and providing that consistent platform to be able to do that. When you start to look at how you piece this together, I mentioned the application developer, I mentioned the applications that they build, and then I mentioned the data scientists and the MLOps and the models that they build. The importance of all of this is because we're moving towards a world where every application needs to be intelligent. It's now the new differentiator for apps coming out. If you are building an application and you're not thinking about how AI can be infused into it and it can augment the benefits to a customer, then that's something that your competitors probably are thinking about. We already know, almost every C-level executive, they're asking these very same questions. We know we need to do something with AI, but we don't quite know what. And a lot of them are questioning, well, what is the right avenue to go down? Can we even do these things in a way that protects our data, provides the capabilities that our customers are looking for? And so when you look at OpenShift AI and the work that we've done with Intel, it allows customers, it allows developers, partners to be able to do the entire data science process and accelerate their time to market. And so on the top part of this, you have the cycle of building out your models. You gather the data, you do some you grab a model from the open source. It could be Hugging Face, could be somewhere else. And you want to do something with that. You want to be able to fine tune that model, do some RAG augmentation on that, and then deploy that model into an environment that's sustainable. And the data scientists and the MLOps engineer, they're going to cyclically go through and ensure that that model is retrained, retuned for the new data that comes in. Now, on the bottom side of this, you have the application developer, which has a very similar cycle. They develop the code, they go through QA, they deploy the code into production, and then they monitor it as well. Having that same consistent platform to be able to do all of this work, that accelerates the time to market. And so now you have OpenShift and OpenShift AI with all of its capabilities, providing the right automation for you to be able to do this at scale and do it quickly and really break down the barriers for the application developers to interact with the data scientists. It's one cohesive platform. And so we have all the tools here to be able to help you get your models into production faster, help you reduce the costs with the work that we've done with Intel to optimize the infrastructure that you have, and then make it to where the data is the differentiator for you. Having a platform where you can add your own data to the open source models, be able to fine tune on your data, be able to do RAG on your data, that now makes that model that you've done this with the differentiator for you. It's different than if you just take a model from upstream and you immediately add that into your application and there's no differentiator. Right? We're with these tools, with this framework and this platform, you have all the ability to be able to really create that differentiator experience. And so now I want to pass it back over to Sid. He's going to tell you about all the fantastic things that have been going on with Intel in this space and all the innovation that they've been a part of.
Thank you, Sharad. Let's go to the next slide. So I like to actually start by saying that, Intel as a company, we are committed to a vibrant open ecosystem for developers, which includes compute, pervasive connectivity, cloud to edge infrastructure, artificial intelligence, as well as sensing. Now, when we talk about open ecosystem, what we actually mean is it includes open source software, open source hardware, open standards, open specifications, open APIs, and open data models as well. So like I said, we promote openness, we promote choice, and we promote the trust. Intel has done significant contribution over the decades to the open source and the open source community. So Intel has over 20 years of investment across hundreds of independent projects, over 19,000 software engineers. It's #1 Linux kernel corporate contributor since 2007. It's top 10 contributor to Kubernetes, and over 300 community managed projects are run by Intel, 700 member foundations and standard bodies, 6 architectures supported in one API, 700 GitHub projects. Intel is also the Chrome OS leading contributor. So significant contribution, more than 20 years, over more than 20 years. With that, I would like to go to the next slide. So this is the Intel vision, actually, to bring AI everywhere. So what we mean by this is to empower every user at every level by providing multiple technologies at all the layers where they touch. So let's start reviewing this from the top. So right from the large to small, the goal is to unlock the AI continuum with novel applications. The next layer, from training and fine-tuning all the way to inference and deployment, streamline the AI workflow with AI software that will be made available in the open source. All the way from cloud to client, including the data center, simplify the AI infrastructure with scalable systems and solutions, and then create silicon offerings from AI specific to general purpose, all the way from Gaudi, data center GPUs, that is Xeons, Arc, and Intel Core. That is the Intel vision of bringing AI everywhere. Let's go to the next slide. So when we double click on that high level vision, conforming to the similar layers that I just reviewed, this is the whole offering that Intel actually provides. And most of these libraries and frameworks are actually in the open source that are available for use. But please don't get overwhelmed with it because they are meant for certain specific purpose. I will go over at the high level, but not get into each framework and each library. So these frameworks actually span over client, edge, cloud, as well as data center. Let's start from the bottom layer, which is the foundational software. The foundational software includes firmware, BIOS and simulation, operating environment and kernel, virtualization, orchestration of edge as well as cloud native. I'll point out a couple of important ones in each of these layers. So in the operating environment and kernel, you obviously see our partner here, which is Red Hat, prominently featured there. In terms of virtualization, we support multiple different softwares, including Kubernetes and VMware. When it comes to languages, frameworks, tools, and libraries, we support multitude of tools, languages, and frameworks and libraries such as SYCL and OneAPI by Intel, as well as OneCCL. And then in the AI realm, we support large number of libraries which are actually optimized by Intel, including NumPy, Python, PyTorch, TensorFlow, scikit-learn, BigDL, and so on. The topmost layer is the solution services and platforms. So Intel runs several developer programs and resources. I encourage you to go to the Intel website and take a look at them. In terms of platform services and solutions, there are multiple platforms and services as well as solutions that are supported. In terms of AI, Intel has created multiple things such as OpenVINO as well as SIGOPT along with Converge.io. Let's go to the next slide. So there is always a debate between the specialized AI models versus the large foundational models. There is, of course, a cost associated with it, which I will cover in the next slide. So the advantages of going with a large foundational model are their incredible all-in-one, out-of-the-box versatility for text, programming, contextual language learning, as well as plain text summarization. Surprisingly compelling outcomes it provides you, but there are certain challenges. The challenge is that they are very big, over 100 billion parameters to provide that versatility, and therefore they're very expensive. The next slide talks a little bit more about the cost, and we'll go into detail, but it's about 4 million to train, 3 million per month for inferencing. The large model also hallucinates and has lack of explainability as well as intellectual property issues. And they're also frozen in time because they are trained on a particular sample that was taken in a particular time. Whereas if you come at the domain-specific models, the advantages are they're 10 to 100x smaller models while maintaining and improving accuracy. They're economical on general purpose compute, like Sharad mentioned. Many of them, you can actually leverage the CPUs and significantly reduce your cost instead of using the GPUs. In terms of correctness, the source attribution as well as explainability is available, and it can also utilize private or enterprise data. You can actually fine tune or do RAG on them to be more specific to your business. They could be continuously updated with new information. There are several challenges as well. Some of the challenges are reduced range of tasks because they are not so big and they are not so versatile, and it requires a few short fine-tuning as well as indexing. So let's go to the next slide with this. I talked about the cost. Although this whole area of LLMs has seen significant revolution, there are advantages, but there are limitations as well. And one of the biggest limitation is actually the cost. If you look at the training cost, GPT-3 cost about $1.65 million. That's 3,640 petaflop days costs if trained on Google TPU version 3. Whereas GPT-4 training cost was about $40 million. That's 450,000 petaflop days over 7,600 GPUs running for a year. Now, if you come to the inferencing cost, the ChatGPT inference cost is about $40 million to process prompts per month, with 100 million active users. And as you know, they reached that number pretty quickly. If you look at the Bing AI chatbot cost, it's about $4 billion, Bing AI chatbot to serve responses to all of the Bing users. So the cost is humongous for these large language models. And with that, let's go to the next slide, please. So as I discussed before, the specialized models actually enable scale, and they're extremely useful in multiple verticals. I will cover some of the verticals and their applications here. For example, in the education vertical, there could be use cases such as teacher assistant, student student study buddy, or parent chat portal. In the health vertical, it could be drug discovery, doctor assistant, and patient family chatbot. In the finance vertical, it could be algorithmic trading, which is becoming very popular, customer portfolio assistant, and risk or credit assessment. In the retail vertical, it could be product promotion, customer interface and sentiment tool, and image shopping aid. In the government sector, it could be government services assistant, document search and summarization, and live language translation. In the energy sector, it is energy consumption forecasting, which is extremely important, and then operational performance, as well as energy trading assistant. In the automotive sector, it could be autonomous car development, which has caught the imagination of the public, multi-language in car aid, and supply chain optimization. The supply chain optimization is applicable to multiple industries, including retail. In terms of manufacturing, it could be factory automation, predictive maintenance. Predictive maintenance is a very important field in which it could be predictive maintenance of the shop floor equipment, it could be trucks, or it could be airplanes, as well as other vehicles. It could be precision agriculture, and in terms of telco, it could be personalized customer service, network automation, and operational performance. With this, let's go to the next slide, and I would like to hand over to Marcus to discuss the hackathon and the results of the hackathon. Thank you, everybody, for your attention today. Have a wonderful rest of your day.
Thank you so much, Sharad, Sid. That was a pretty impressive presentation, and I enjoyed every second of it. Thank you again for joining us today.